Okay, so this is our statistics project done by Muhammad Sultan, Muhammad Anas, Karim Saadi, and Muhannad. The introduction is that the sleep is a vital biological function that affects various aspects of human health and well-being. Sleep quality and quantity can influence physical, mental, and emotional health, as well as academic performance, social relationships, and lifestyle choices. However, many factors can interfere. ارجع بلش من أولها. برو أنت ليش بتغير؟ أوكي من أولها؟ لا stop the recording start again.
خلاص كمل عادي.
فيك تسوي delete بالآخر يعني؟
ايوه كمل. انت كيف
أوكي
كيف عارف انك خلصت؟
راح أجي بس until patterns.
اوكي يلا 1
أول
2
paragraph.
3.
Okay, sleep is a vital biological function that affects various aspects of human health and well-being. Sleep quality and quantity can influence physical, mental, and emotional health, as well as academic performance, social relationships, and lifestyle choices. However, many factors can interfere with sleep, such as stress, noise, light, caffeine, and electronic devices. Therefore, it is important to understand how different people sleep and what factors affect their sleep patterns. Table of contents. We have all the contents ready here. Data collection, normality test, point estimations and confidence interval, hypothesis test, the goodness of fit test to check the normality, correlation, linear regression, other chi-square test, ANOVA, and application of non-parametric tests. Data collection. Here's our data given. We were able to hand out questionnaires to a sample of Bahçeşehir University students in Istanbul with the cooperation of a friend, asking them, how many hours do you sleep in a day? Data collection. Here's our code given. Importing the Excel file name as data sample, which contains the information that we need. Using RStudio, we get the mean, median, first quartile, and the third quartile by the semi function. And that's the code given.
In our studio
Yes.
application, we use the function hist to view the histogram of the data derived. A normal QQ plot. The normal QQ plot can be shown by the QQ norm function. This is the diagram and this is our table. A box plot. By using RStudio, we use the function box plot. And this is our table. Normal
Muhammad,
test.
your mic.
Okay, there are many ways to test the normality of the data. One of the most used is Sharpe test. If the p-value of the data is longer than 0.05, we fail to reject the null hypothesis. However, if it is more than or equal to 0.05, the null hypothesis is rejected. And here is the coding and also the table. Point estimation and confidence interval. Point estimation. Finding an indication value of a parameter statistics such as the mean or average of population using sample drawn at random from the population. Point estimation is a process used to determine a single value or statistics that will be said the best guess or best estimate of parameter of an unknown. And here is the most efficient point estimator and the small invariance of all and based on constant estimator. And here is the coding.
Okay, confidence interval. In statistics, refers to the probability that the population parameter will fall between a set values for a certain portion of times. We will find the confidence interval by t-test. These are the codings given, one table and the other. Therefore, we are looking to find the confidence interval for sigma using chi-square test. It is shown above that we've done a 95% confidence interval for sigma by RStudio, and this is the RStudio code given for us. Hypothesis test. When we are gathering the data, we also take care of the gender difference, which is really important, since the study also aimed to investigate the average number of hours of sleep for males and females. Two individuals, Muhammad and Abdurrahman, had different claims about the average sleep duration for each gender. Muhammad claimed that males sleep an average of 4 hours, while Abdurrahman believed that females sleep less, which is 9 hours on average. To validate these claims, a hypothesis test was conducted using R. to find the true mean of each gender and see if the average numbers of hours of sleep for males are larger than the average numbers of hours of sleep for females. The first hypothesis test. The first hypothesis test, the null hypothesis, H0, stated that the average number of hours sleep for the males is 4, while the alternative hypothesis, H1, stated that it is not equal to 4. And here's the code given, which you can all see. Second hypothesis test. Moving on to the second hypothesis, the null hypothesis, which is the H0, stated that the average number of hours of sleep for females is 9, while the alternative hypothesis, H1, stated that it is less than 9. While you can see in the code, it's also written.
The goodness of fit test to check the normality. We wish to determine whether or not the table is regularly distributed. We test the normality using the goodness of the fit test, and will do so in R. We first determine the interval midpoints for each class. And here is the student sleep hours and the number of each category, frequency and percent. Correlation. In order to find out if there is a correlation between the student age and number of hours they spend sleeping, we also ask the student for their ages when we gather the data. And here's the table of student age and hours of sleeping. We defined a correlation coefficient of minus 0.105 represent a weak negative correlation, and since minus 0.105474 is relatively close to 0, it suggests a weak correlation between the variables. And here is the coding.
Linear regression. When we used RStudio, we could specify a linear regression model by using some of the function Lm, and it gave us some information below. Now we will use the plot to find our regression chart. This is the table below. Other chi-square test. In this table, we show that we have 3 categories, which are the most 3 perfect more hours to sleep in our data set. Ours simply is a condition from 30 students. We will see if we could reject this claim that 3 is a performance to sleep, like the table below. Hours of sleeping 11 a.m., 12 a.m., and 1 a.m. Using chi-square for dependence and independence. In this table, we specify the number of students in each facility with the most common hours of sleeping. In our data set, we will find there is a relation between them or no by using the chi-square test. This is the table below. Hours of sleeping 11 p.m., 12 p.m., 1 a.m. in the total.
ANOVA. ANOVA is an abbreviation of analysis of variance. It's a statistical approach for comparing and analyzing the means of the 2 or more group. In ANOVA, analysis is common to have multiple group or condition to compare. Therefore, we create hypothetically example with the 3 group 1 and group 2 and group 3 to demonstrate how the ANOVA can be performed using the AOV function in RStudio.
So the application of non-parametric test. We can explore application of non-parametric tests in RStudio. Let's start with some commonly used non-parametric tests. The Wilson single signed rank test with the Kruskal-Wallis test. Let's start with the Kruskal-Wallis test. May be used to compare the amount of time people spending sleeping in several independent groupings, such as the various university terms. Here's an illustration while giving in the data down below. Second non-parametric, the Wilson rank sum test for period data may be used to compare the amount of time spent sleeping between 2 related groups. For example, before and after an intervention for each student. Here's an illustration by the code given. By the conclusion, in this report, we used RStudio to conduct a comprehensive statistical analysis of the data set that contains the hours of sleep of 30 BAU university students. We described and visualized the data assessed is the normality and calculated point estimates and the confidence intervals and performed hypothesis testing. We also applied goodness of fit test, built a linear regression model, ran ANOVA and chi-square test, and used non-parametric methods, which is the both, This report demonstrates how statistics can help to understand and interpret in real life data. And thank you for attending our